In this video, we're going to look at an application that is common in a lot of different math classes, from statistics to math modeling to algebra. We are going to look at the best fit line and some other models. We're going to take a set of points, see how to plot those with Geogebra quickly and efficiently, and then how to find either the best fit line or, to say, some other model. Maybe it's exponential, logarithmic. So this is going to get a little tight on this screen to fit into a YouTube video, but you can add a third screen. This is called the algebra view. This is the graphical view. You can add a spreadsheet view. Okay, when you do that, the only problem is we're really starting to, at least here without maximizing this window to my entire computer screen size, it's going to be a little small. But in the spreadsheet, you can type in points. So I have a set of points that are going to be the size of houses in 100 square feet. So 9, 15, 10, 11, and 10. So that's 900 square feet, 1,500 square feet. We have the size of houses. And then we have their cost in thousands of dollars. 36, 80, 44, 55, and 35. Okay, so somewhat manufactured data, but we have a set of points here. You can then just highlight the list. I just clicked, held down and dragged, right click, and you can create a list of points. Okay. Two things happen when you do that. One, you get the representation over here in the algebra view, and it names them P1 through P5. They're also plotted on the graph, though we can't necessarily see that right now. So I'm going to move this view over and change this window. So I need to click right on the axis and select the graphics view. So for the x-axis, our numbers ranged from 9 to 15. So let's set them. I always like to see the axis. Let's do a negative. -1 to, how about 16? And then on the y-axis, those numbers ranged, looks like from 35 up to 80. So let's go from about -10 to 90. And now we can see the points that we plotted. Okay. So if you just want to do the best fit line, there's an option under the line tools for the best fit line. You just highlight and make sure you select them all, and boom, it automatically does it. Okay. Now the advantage here, let me move this over a little bit, and then take the tool to move this over a little bit. The representations are dynamically linked. If I change anything, it will change all of these. If I can drag a point, it moves the best fit line, but it also changes, which has its equation over here. And it also changes the coordinates in the list here and here. So I can change points on the graph, and the other two representations are updated. I can change a point. These are tied to the list over here, so I can't change them that way, but I can change a number here. If I wanted to change this 9 to a 20, it automatically updates. But let's put it back. Okay, and so again, I'm going to hide the points a little bit. So that's one way to make the best fit line. Let me take it away or just hide it. If you just click on the little circle, you can hide things off and on. Another way is to type in the command, and if you look in the command, these are all under fit. If you scroll down, you can fit an exponential, fit a line, fit line x. That would be where you swap the role of x and y. Your output is x, your input's y. Fit a log, fit a logistics, fit a polynomial, fit a power function, fit a sign. So let's do several of those. Let's fit a line to these points. So fit a line. Once you start typing, you'll see it starts recognizing commands. We're going to fit a line to list 1. And there we go. Let's fit an exponential. So fit exp of list 1. And let's see, I left out the 1. And there we get an exponential function. You see the formulas over here. Here were the lines, the best fit lines. I entered it using the icon and then using the command. Here's the exponential. It does of the form a times e to the kx. And let's see, what other types can we do? We could do a logarithm, so we could fit a log to list 1. And you see it uses a natural log. We have an a plus b times natural log of x. And let's hide a couple of those. And which other regressions? We could fit line x, which just swaps the role of x and y. Fit line x of list 1. So you'll have the same regression coefficient, but instead of plotting y as a function of x, it's plotting x as a function of y. So it's basically the inverse of the other one. Let's turn that off. And you can do a logistics function, which is very useful in applications. So we're going to fit logistic to list 1. And you get the S-curve. Okay. You can fit a polynomial. Let's see, fit poly. There you have to tell it list 1 and then I believe the power of the polynomial. Let's say we wanted to fit this with like a 4th degree polynomial. It'll tell me if I'm wrong and we'll fix it, but I believe that's how you do it. Told me undefined. Let's try this. It'll give me an error, but it'll tell me the way. Yeah, list of points, degree of the polynomial. So let's try a different degree. Perhaps we just didn't have enough points for that particular type. Now there we can fit it with a quadratic. We can change that. Let's do a 3rd degree. So we have a cubic. Didn't seem to like the quartic. I guess, yeah, these two share the same x value, so we only have a few points there for it to use. But that's how you do a polynomial. You have to tell it the list and the degree you want the polynomial to be. You can also do a power function similarly. Fit power. Let's try just first list 1. And there's the power function, which is something times x to a power, and it finds the appropriate power. So again, just look at the command menu, scroll down to fit, and you'll see the different type. I didn't do sign because I'm going to do a different example of that in a second. Okay, so you can fit all of these different types here. Okay, so very simple. Just define your list, make a list of points, and then using that name, you can fit a line to list 1, fit an exponential to list 1, and so forth. Okay. Let me do one more example for you. I'm going to start off new. I'm going to pull over the stat view. So I went and I found for each of the 12 months, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The average high temperature in Atlanta, we have 50.4 in January, 55, 64.2, I just looked this up on the web, 72.7, 79.5, getting to the hot summers, 85.8, 88, 87.1, 81.9, then in October, 72.7, in November, 63.3, and finally in December, 54. Let's plot those, and they will actually have a sinusoidal shape, a trig function. So create a list of points. I'm going to hide this view now. I'm just going to turn it off. I'm going to go up to my views, turn the spreadsheet view off, and let's change the axis again. So click right on the axis, graphics view. So for the x-axis, let's see, we did the months. Let's go from -1 to 13 to make sure we overshoot each one, and we'll see the months. And then our temperatures on the y-axis, again, let's leave it negative. Let's go -10 up to 90. Should reach the highest one. And there we see these that follow a very, very close to a trig function. So we're going to fit a sign to that. Fit sign to list 1. And there you go. We see an extremely close fit that the average high temperatures actually follow a sine curve, or you could do a cosine curve. But the built-in function we have here is sine.